Hi everyone, welcome to the Merchant Construct-preneurs and Tutors, your YouTube channel for learning about construction and engineering. Before we go ahead, kindly click on the like button, share and subscribe to this channel, the Merchant Construct-preneurs and Tutors. So today we'll be looking at how load is transferred in a building structure, as you can see in the frame beside. That's the building structure. So now we are going to know what structures are and how loads is being transferred in a structure, the assumptions that are made, and how to determine these things. Okay, so structures are designed to withstand loads safely without undergoing any excessive deformation due to applied loads. This means that the design strength of the structural material should be greater than the design loads. I hope you understand this. A material should be able to have enough strength to be able to withstand any load that is being imposed on it. Just look at yourself standing. If you want to lift, let's say, a bucket of water, you need to be strong enough to be able to carry it. You cannot give a child a bucket of water, like say 5 liters to carry. Say a 2-year-old child, it's very, very heavy. The child is not strong enough to be able to withstand that load. So this is what we are talking about. So what is design load? In structural engineering, a design load is the anticipated force or pressure that a structure will need to withstand during its lifespan. These loads are used by engineers to determine the size, strength, and reinforcement requirements for various structural components. What is saying is the load is what the structure is anticipated to carry, expected to carry, just as I explained using the little child. Okay, so once we know the design load, we'll be able to determine the sizes of the elements, the positioning, and the orientation. So now, the loads acting on the structures are categorized into two based on the direction of action. There will be gravity loads and the lateral loads. The gravity loads are vertical loads that act downwards on the structure, such as the weight of the structure itself, that is the dead load, the weight of occupants, that is the life load, humans walking around the structure. Now, the weight of the contents are also like the machines you install, the table, the furniture, the fridge, and every other thing you need. And then the weight of the snow or rain for environmental loads, although these environmental loads are insignificant. Now the second one is the lateral loads. Now the lateral loads, these are horizontal loads that act on the structure from the side. They are not acting on it vertically, it acts on the side, external loads. So they are the wind loads and the earthquake forces. So having known these categories of load now the designer should be able to determine the particular combination of loads, life load, dead load, wind loads, environmental load. Be able to know the one that has the highest, that is maximum dead and imposed load, which is likely to produce the most adverse effects on the structure in terms of bending moment, in terms of shear force, in terms of deflection. So these three components, these three terms here used are what will actually make this building feel like may not be able to carry this thing. So the maximum load that this building that is going to impose on the building that will make it want to fail in terms of bending, in terms of shear force, in terms of deflection. So so looking at it now, so let us look at what characteristic load and design load is. Now characteristic load refers to the actual weight of the building materials per meter or per meter square, while the design load is expressed as a function of partial factor of safety multiplied by the characteristic load. This statement here is saying that the manufacturer's the dimension or the weight from the manufacturer, that is the characteristic load. Then the design load, you are going to have some factor of safety in case of malfunction, in case of the size is different, in case you want to change your mind. You get, like humans, the weight of today in next 2 weeks might not be the same weight, so you need to check the partial factor of safety just to be sure that in case this is no longer this other is required. So now for the design load now, it's expressed according to BS 2110 as 1.4 GK plus 1.6 QK, where we have GK as the characteristic dead load, we have QK as the characteristics imposed load. Then the partial factor of safety for the dead load is 1.4, that is the prefix in front of GK, while 1.6 is the prefix in front of QK, represents the partial factor of safety for life loads. That is according to BS 8110. I know we have Euro code now, and then the partial factor of safety is slightly different, but we are working with BS 8110 here. So now, the types of loads acting on the structure, what we are going to be determining, what we are going to use to determine things. We know we talked about the gravity load and the lateral loads, where the gravity load is. So we have dead loads. These are static or permanent loads acting vertically downwards on the structure. So this includes the self-weight of the building, the finishes, partition, fixtures, everything that is permanent, that is not movable. Those are dead loads. So the weight of the wall is permanent. The beam, the columns, the plastering, the partitions, everything that is permanent there, they are all dead loads. Now looking at the second type is the have life loads or the imposed loads. These are dynamic loads acting vertically downwards on the structure. So this includes the weight of the roof, occupants, furniture, and any other movable items in the structure. So it's denoted as QK. So this one now is talking about those that can be removed from one point to another. Those ones are life load or imposed loads. Can be moved. You can move this your machine from here, your fridge, refrigerator from one point to another. If it's the office setting, you can move the what's the name? The photocopy machine from one point to another. So we have the wind loads. Now the wind load is another type of load that exerts wind pressure on the structure. So it acts laterally, usually considered in high-rise buildings and prone to excessive wind forces. So it's denoted as WK. So for high-rise buildings, we will consider wind load in it, in the design or in the design. So environmental loads are insignificant, like the weight of the rain and snow. But when you have excessive snow, you have to consider it in your design. But for the basics where you have a fair weather, you can ignore it. So design loads. Design load is obtained from the combination of both maximum life and imposed load acting on the structure. So it's estimated to act on the structure according to BS 8110 part 1 as 1.4 GK plus 1.6 QK. So I'm referencing BS 8110. So some other standards are there. You have the Euro code. I think I have other codes, but what I'm referencing is the BS 8110. So once the design loads acting on the structure is estimated, it is possible to calculate the loads acting on the individual elements. Therefore, the design loads determines the sizing, orientation, and positioning of various structural elements for safe transfer of loads to the ground. So if you are able to talk about every load that is there, so each of the elements now, what is the load that is being transferred to it? You get? So because we talked about transferring of load, the principle of load transfer. So for the loads to be transferred safely from the roof, that is from the highest point, to the foundation and then to the ground, the designer needs to make necessary assumptions so as to help him or her calculate approximately the estimated load and path of transmission. So we need to make some logical assumptions that okay, this load is going to pass through from here to here. This is exerting this particular load based on its dimensions and the unit weight. You'll be able to estimate. So the assumptions to be made are: one, the support conditions. Now we assume that all joints in the structure are pinned. Now in the last lecture we talked about pin support, talk about roller support. I talk about even simply supported beams. So I assume that everything is pinned. Now the part of load transfer is assumed that the sequence of load transfer is from the roof loads to the floor loads to the beams and then to the columns and then to the foundation and finally to the ground. So roof, columns to slab, slab to beam, beam to columns, just like that. You get to the foundation and then ultimately it transfers it safely to the load. So each of these elements needs to be strong enough to be able to withstand this load as it's being transferred from the top to the down. That's why you find out in most structures the structural elements at the ground floor or at the basement, as the case may be, are usually robust, more robust than that at the top. At the top it reduces. So principle of load transfer in the structure. The principle of load transfer is explained using the illustration. You have the, as I said, the roof, you have the floors, so the beams, the columns, the foundation footings, the ground. So just using this as an illustration to explain how loads are being transferred in the structure. So it is pertinent to know that the direction of load transfer on the structure is from the top to the foundation. So it is usually horizontal for structural elements such as slab. The direction of load transfer now, so very horizontal for some elements such as slab and beams, while for columns and reinforced concrete wall, the direction of load transfer is downward vertical. I hope you understand that part. So while we go further, you understand it better and then clearer. Good. So for the roof beam level, so we have started breaking this thing down, starting from the top, the roof. So from the roof beam level, the roof beam collects load from the roof structure and the self weight of the roof beam, and then it transfers it to the column. You get the roof structure transfers to the column, also the roof beam also transfers to the column. So it is assumed that the load is transferred from the midpoint out towards the support, the column supports. So as you can see in the diagram there, it moves each way from the midpoint, it moves to the column support. So for the slab, the load from the self weight of the slab and other imposed loads on the slab is transferred to the beam supporting it from beneath. It is assumed that the load is transferred from the midpoint of the slab out towards the beam on either side along the long span. So it's the same thing as the beam, same direction at which the beam transfers the load. That is how the slab also transfers. So from the midpoint, it takes it to the supports. And slabs, for solid slabs, are usually supported by beams, unless you have a flat slab where you don't have any beam. So for the beams, the loads from the self weight of the beam and then of the imposed loads from the slab is transferred to the column supporting it from beneath. So it is assumed that the load is transferred from the midpoint of the beam outwards to the column support on either side, as you can see illustrated in the diagram. So you have the column beneath, you have the beam, and you have the slab. So for the columns at the ground floor, the loads from the self weight of the beam and other imposed load from other structural members. I'm talking about the ground floor now. So the ground floor is collecting everything from the top. So the loads from the beams above the columns and also from the slab and other structural elements are transferred vertically downwards to the foundation, as you can see there. See the arrow from the column, it's taking it down to the foundation footing. So the foundation, after the foundation has received it, the foundation then transfers it to the ground on which it is sitting on. It's sitting on the ground. It is not just staying on staying on the surface. So it needs to transfer the load safely. So the loads carried by the columns are transferred vertically downwards to the foundation. The foundation, due to its structure, transfers all these loads safely to the ground. And what makes this thing transfer this thing safely to the ground is because of the structure, the design of each of these structural elements, how it is being done. So now, all what we have said, it is being illustrated in this diagram, in this frame here. So looking at it, we have the roof level, like the roof beam. See the direction of the forces from the midpoint down to the column, you have it there. Then you have on the next floor, this shaded, the hatch part is the slab. So you see the directions. For the other one, you have the beam. Look at the direction down to the column from the foundation has taken its own, taking it down to the what is the name? That's taking it down to the soil. So I hope we understand this load transfer. So the assumptions are made and they are right. Looking at it, so it transfers from beams to columns, from slab to beam, beams to column, does the same route, it takes that same route. So you understand? Okay, thank you for watching this educative content. For more educative content about construction practices and engineering, kindly subscribe to this channel, The Merchant, Construct-preneurs and Tutors. So you find it, the merchants, constructpreneurs and tutors. Kindly subscribe to this channel. Thank you very much for watching. See you next time for another exciting episode of learning and knowledge sharing. Kindly hit on the share button, like, and also subscribe to this channel. Thank you very much.